Every student will find a distillation kit on their desk, and it is important not to interchange any of these components with your neighbors. You will set up the distillation apparatus as instructed by your instructor, and I will now walk you through it. The heart of your apparatus is a round bottom flask, which has to be clamped securely. The round bottom flask is now sitting inside a heating mantle, which is placed on a lab jack or lab lift, the blue thing that allows to raise or lower the heating mantle so that it can be removed at any time throughout the experiment. This setup allows to determine at what height the round bottom flask is best secured to the frame. To secure it, you need a clamp bracket and a finger clamp, and you find them in a drawer in the lab, as will be pointed out to you. Secure the round bottom flask straight and nice and tight, but not too tight. Using a funnel with a narrow neck, you pour the fermented batch into the round bottom flask. Now the heating mantle can be raised until it has firm contact with the wall of the round bottom flask, but don't push too hard. Adding porous boiling chips will prevent large vapor bubbles to form when your batch is boiling, so-called bleavies, boiling, liquid expanding, vapor explosions can be prevented by that. The distillation column is a so-called Vigreux column. It has small glass projections pointing towards the inside of the column, which improve the reflux dynamics. The distillation column fits into the round bottom flask with a conical joint which consists of ground glass, allowing for a gas-tight connection. And it is good practice to very lightly grease that ground frosted glass so that it does not freeze throughout the procedure and can be easily disassembled at the end. It is important to apply that grease really sparingly so that it does not contaminate your process. You want the distillation column to be sitting in your flask nice and straight, and it does not have to be secured. Next, we add a T-shaped joint piece which provides access for the thermometer and it directs the vapors towards the condenser. We can secure the T-shaped joint piece with a plastic clamp. That's just to make sure it doesn't break, fall out at the end when we disassemble the apparatus. We also use a plastic clamp to attach the condenser. The condenser is a glass tube with an external glass wall through which the cooling water will flow. The cooling water will make that condenser relatively heavy, and it could pull on the apparatus and then stop it from being gas tight and leaky. And therefore it's a good idea to support the condenser with an additional finger clamp. To put that finger clamp into place is a bit tricky, but remember it's only supposed to support it lightly and does not have to be clamped firmly. So be really gentle. It just has to be some gentle support. We now attach another glass tube to the end of the condenser. It's L-shaped or has a 90-degree angle, sometimes called an elbow glass tube. It will direct the droplets of the distillate into some container. Now connect one of the rubber tubes to a faucet. Which one? Well, the cold water should flow in the opposite direction of the vapor. You find a glass tube with a rubber sleeve in your set, which allows for the thermometer to be inserted. Carefully slide the thermometer, turning it back and forth into that sleeve so that it reaches far enough so that the reservoir for the thermometer liquid reaches far enough into your T-shaped glass joint to be in the area where the vapors condense. Observe how we secured the rubber tube with the outflow from the condenser before we really carefully, slowly open up the faucet and let the water run through the condenser, right? And then we make sure that we have a good, steady flow of water running through the condenser. Next, we secure a platform that allows for a graduated cylinder to be placed under the condenser and collect the distillate. So now we obtain a rheostat. We connect the rheostat to the power outlet and connect the heating mantle to the rheostat, dial the rheostat to 0% power output, and then switch it on. The red light should indicate that the rheostat is working, and now we can dial it to 100% power output to get the maximum heating effect. It will now take a couple of minutes for your fermented batch to heat up. The thermometer still shows room temperature, but after a couple of minutes you will see the first traces of condensation. And when the condensation is visible in the bottom of your distillation column, you dial your rheostat back to 70% of power output. Now you can observe how reflux establishes in the distillation column, how the vapor front rises inside that distillation column until it reaches the top of the column, and the temperature quickly starts to rise until it reaches the boiling point of ethanol, or more particular of the ethanol azeotrope, 78 degrees. And soon after, the first droplets of distillate will be produced and collected in the graduated cylinder. Now it only takes a couple more seconds until you have several milliliters collected and you can stop the experiment. To end your experiment, you remove the heat source, the heating mantle, unplug and switch off the rheostat and wait for everything to cool down. Then you disassemble your distillation apparatus in reverse order as instructed by your teacher. And hopefully this was the last lab of your day and you can go home and have a nap.